Imagine dropping a stone into a still pond. You see ripples spread out across the surface. Now, imagine the universe itself is that pond. And instead of a stone, you have two black holes crashing into each other. Those ripples in the fabric of the universe are called gravitational waves. They are not made of light. They are not made of matter. They are literally ripples in the shape of space and time itself. Welcome to Großdenken, everyone. Today we are going to explore what these cosmic ripples are, how we finally caught one, and why it is changing our understanding of the universe. Please support this channel by just subscribing. That would mean a great help. The story begins with Albert Einstein. In 1916, just a year after publishing his revolutionary general theory of relativity, he made a mind-bending prediction. Einstein said that gravity is not a force, but the curvature of spacetime caused by massive objects. Think of a trampoline. A heavy ball sags the fabric and other objects roll towards it. Einstein's math showed that when very massive objects accelerate, like two stars or black holes orbiting each other, they should create ripples in this spacetime fabric. These ripples would travel outward at the speed of light, carrying energy away with them. He called them gravitational waves. It was an incredible idea. But Einstein himself doubted we would ever be able to detect them. He thought they would be far too weak. For the next century, they remained just a theory. The first hard evidence didn't come from a direct detection, but from observing a cosmic clock. In 1974, astronomers Russell Hulse and Joseph Taylor discovered a binary pulsar, two dead stars orbiting each other at incredible speeds. According to Einstein, this system should be losing energy by radiating gravitational waves. This would cause the stars to spiral closer, making their orbital period shorter. For years, they tracked the pulsar's signals and found the orbital period was decreasing by precisely the amount Einstein predicted, to within 0.5%. It was the first proof that gravitational waves were real. They won the Nobel Prize in Physics in 1993. But this was like seeing the wind by watching the trees sway. Scientists wanted to feel the wind itself, to detect the gravitational waves directly. To directly detect these ripples, scientists built incredible machines. The most famous is LIGO, the Laser Interferometer Gravitational Wave Observatory. It has two observatories in the United States, each with two 4-kilometer-long arms arranged in an L shape. The concept is genius. A laser beam is split and sent down both arms. When a gravitational wave passes, it stretches one arm while shrinking the other by an incredibly tiny amount. This difference changes the pattern of the laser light. To detect a wave, LIGO must measure a change in distance 10,000 times smaller than the diameter of a proton. And on September 14, 2015, it happened. LIGO detected the signal of two black holes, 29 and 36 times the mass of our Sun, merging 1.3 billion light-years away. The collision converted about 3 times the mass of our Sun into pure energy in the form of gravitational waves, making it the most powerful event ever observed. Humanity had finally heard the universe with gravity, not light. For over 100 years, we have studied the cosmos by looking at light. Gravitational waves give us a completely new sense. They let us hear the dark, invisible parts of the universe, black holes and neutron stars, and study events that are otherwise unobservable. Today, LIGO and its partners routinely detect black hole mergers, transforming gravitational wave astronomy from science fiction into a new frontier of discovery. What will we discover next with our new cosmic ears? That is what makes this one of the most exciting times in physics. Thanks for watching, and hit subscribe for more deep dives into the mysteries of the universe.